We have been talking a lot about hydrocarbons, basically compounds made up of only hydrogen and carbon atoms. And we saw that there are three main families: alkanes, alkenes, and alkynes. There are other families, but we'll talk about them in a separate video. Over here, we are going to look at more members of each of these families. And with the help of that, we will be arriving at a general molecular formula for each of these families. Well, what is that? Well, a general molecular formula gives a relationship between the number of carbon atoms and the hydrogen atoms in a particular family. For example, in alkene family, for every carbon atom, you have twice the number of hydrogen atoms. Okay, that's the relationship. Now, if you're wondering why is this important, how is this helpful? So just imagine if in future you discover a new organic compound which has around 50 carbon atoms and 100 hydrogen atoms. Then just by knowing the general molecular formula, you will be able to categorize this compound in any one of these families. And with that, you will be able to predict its chemical properties pretty fast. Because you know what? All the members of a certain family will have similar chemical properties. So isn't that very convenient? So that's why we are going to find out the general molecular formula of each of these families. Let's begin. Now let's start with the alkane family. See, by definition, they are acyclic hydrocarbons. Acyclic meaning that the carbon atoms are not arranged in a circular fashion. See, this is a cyclic hydrocarbon. Here the carbon atoms are arranged in a circular manner, right? In alkanes, they won't be. They will be in an open chain structure. Okay. And the second part is that they only have single bonds between the carbon atoms. All the carbon atoms will be connected with a single bond. No double or a triple bond will be present between them. So probably the simplest alkane is going to be one with one single carbon. One single carbon, methane. And this carbon is going to have 4 valence electrons, which it will be sharing with 4 hydrogen atoms to fulfill its octet and be stable. So this is the first member of the alkane family. But that's not it. I can keep on replacing a hydrogen atom with another carbon atom and keep on elongating this chain. Something like this. Here I replace a hydrogen atom with another carbon atom. So see, here this carbon is sharing 1 electron with this carbon, and it will be sharing the rest of the 3 electrons with hydrogen atoms. So this is also a valid member of the alkane family. See, this is acyclic and all the carbon atoms have single bonds with each other. There are no double or triple bonds in this compound, right? So this is another alkane. Now similarly, I can keep on elongating this chain. I can take a copy of this compound and replace a hydrogen with another carbon and fulfill its valencies with hydrogens. So this is another member of the alkane family. There are 3 carbon atoms in this particular chain. I can keep on doing this again. This has 4 carbon atoms. So you can imagine that similarly, I can keep on forming newer and newer alkane members. I can have 5 carbon chain or 10 carbon chain or 20 carbon chain. So here we saw how to find out the members of the alkane family. Now let's try to find out their general molecular formula. For this, let's try to write down the molecular formula of each of these compounds. So methane here has 1 carbon and 4 hydrogens. So its formula is going to be C1C and H4 because there are 4 hydrogen atoms. Similarly, this compound, this has 2 carbon atoms. So C2, and there are 6 hydrogen atoms. So C2H6. Similarly, can you pause the video and try to find out the molecular formula of these 2 molecules? Now that you have tried it, let's see. So this one has 3 carbon atoms, so C3, and it has 8 hydrogen atoms, so C3H8. Similarly, this one has 4 carbon atoms, so C4, and it has 10 hydrogen atoms. Oh, oops, let me change the color. C4H10. This is going to be its molecular formula. Now let's see what is the general molecular formula of alkane family. Meaning, what is the common relationship between the number of carbon atoms and the hydrogen atoms in every alkane. So basically what we are trying to find out is if given an alkane which has n carbon atoms, can we somehow tell how many hydrogen atoms are going to be present in this alkane? Okay, so let's see. So over here I see that for 2 carbon atoms, there are 6 hydrogen atoms. Here for 3, there are 8. Here for 4 carbon, there are 10 hydrogen atoms. What is the relationship between the numbers of carbon and hydrogen atoms? If we can find that, we can arrive at a general molecular formula. So can you pause the video over here and try to figure out the relationship between these two numbers? Pause and try by yourself first. Now if you have tried it, let's see. So here maybe if I multiply 2 with 3, then I get 6. So maybe into 3 is the relationship. Let's try that out. 3 into 3, this is going to be giving me 9 and not 8. So multiplying by 3 is not the right relationship. How about addition? Maybe if I add 4 over here, 4 plus 2, 6. Okay, let's add 4 over here. No, I'm not getting 8 over here, right? So adding 4 is also not going to be the relationship. How about I do both? I multiply and then I add some number. Like for example, I multiply 2 with 2, 2 2s are 4, plus 2. Okay, then I am getting 6. Let's try the same over here. 3 into 2 and plus 2. Maybe this is the relationship. Into 2 and plus 2. So 3 2s are 6, plus 2 is 8. Oh wow, I'm getting this number. Again, let's try it one more time. Into 2 and plus 2. 4 2s are 8, plus 2 is 10. So yes, this is the relationship for alkane family. Now if you take the carbon atom and multiply it by 2 and add 2 to it, then you will get the number of hydrogen atoms. Okay, so over here our general formula is going to be, if the number of carbon atoms are n, then I'm going to multiply this by 2 first. So that will give me 2n, and then I'm going to add 2 to it. This will be the number of hydrogen atoms present. So this is the general molecular formula for the alkane family. All the alkanes will have carbon and hydrogen according to this ratio only. If tomorrow you come across any alkane which has, let's say, 25 carbons, then the number of hydrogens will be twice of 25, which is 50, plus 2, 52. So C25H52 will be the molecular formula. Isn't that very convenient? Now let's move on to alkenes. So alkenes also are acyclic hydrocarbons, meaning the carbon atoms are not arranged in a circular pattern. And they have at least one pair of carbon atoms with a double bond between them. Okay, there can be more, but at least one pair of carbon atoms. And this is an example of alkene. Now, can you pause the video and think about whether there can be an alkene with just one single carbon atom? Pause and think. So, no, right, that's not possible because we know that alkenes need at least one pair of carbon atom with a double bond in between them. So one pair means at least we need 2 carbons, right? So an alkene with a single carbon atom is not possible. So here I have 2 carbons with a double bond in between them. Okay, now that this carbon is sharing 2 electrons with this carbon, there are 2 more valencies, 2 more electrons pending, right? These will be satisfied by hydrogen. Hydrogen. Similarly over here, hydrogen and hydrogen. Okay, now this is just the first member. Just like how in alkanes, we took a copy of the first alkane and we replaced hydrogen with more and more carbon atoms and elongated the chain, we can do similar things over here also. Let's do that. Now this carbon is sharing 1 electron with this carbon. Now the 3 pending electrons will be shared with hydrogen atoms. So this is another member of the alkene family. See, this is acyclic in nature and it has got 1 pair of carbon atom with a double bond in between them. See, there can be more than one, okay? There can be a double bond over here also between these 2 carbon. But in this video, we are talking about simple alkenes, meaning alkenes which have only 1 pair of carbon atom with a double bond in between them. And we will be trying to write the general molecular formula of simple alkenes, okay? Now, before doing that, let's write the next member of this family. Let's take a copy of this. And let's replace the hydrogen atom with another carbon. So this is another member of the simple alkene family. Okay. Now let's try to find out their molecular formulas. So over here, I can see that there are 2 carbons. So C2, and then there are 4 hydrogens. So C2H4. This will be its molecular formula. This has 3 carbons. So C3 and 1, 2, 3, 4, 5, 6. 6 hydrogens. This has 1, 2, 3, 4 carbons. C4. 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens. So over here you can clearly see that the number of hydrogen atoms, they are double the number of carbon atoms. See over here 4, 2, 6, 3, 8 and 4. That means the general molecular formula can be Cn. If there are n carbons, then the number of hydrogens have to be twice in number, 2n. So this is the general molecular formula of alkenes. Now let's talk about alkynes. See, alkynes are also acyclic hydrocarbons, but they have at least one pair of carbon atoms with a triple bond in between them. A triple bond, okay? And for similar reasons like alkenes, we cannot have an alkyne with just one carbon atom. We will at least need two carbon atoms with a triple bond in between them. So the simplest alkyne will have at least two carbons in it, okay? Two carbons, and there will be a triple bond between them, okay? Now, since this carbon is sharing its 3 electrons with this carbon, it has one more electron left in its valence shell, which it will share with hydrogen atom. Similarly, this will share with hydrogen atom. So this is ethyne. This is your simplest alkyne. And now, just like how we did in case of alkanes and alkenes, here also we can increase this, we can elongate this carbon chain and form many other members of the alkyne family by replacing hydrogen with more and more carbon atoms. So let's do that. If we copy paste and replace this hydrogen with a carbon atom, then we will get something like this. See, here we have a chain of 3 carbon atoms, and one pair of carbon atoms have a triple bond between them. So this is also a simple alkyne. Now let's elongate the chain by replacing this hydrogen with another carbon. Then we will get something like this. Here we have a chain of 4 carbon atoms, and one pair of carbon atoms have a triple bond in between them. So this is also a simple alkyne. See, over here we can have more than one pair of carbon atoms with triple bond. Like we can have a triple bond over here also. But see, those are complex structures. In this video, we are not talking about them. Here, we are only talking about simple alkynes, meaning alkynes which have only one pair of carbon atoms with a triple bond in between them. Now let's try to figure out the general molecular formula of simple alkynes. Now, before I do that, can you pause the video and try it by yourself? Basically, you are trying to find out if there are n carbons in a simple alkyne, then how many hydrogens will it have? Okay, pause and try it by yourself first. Now, if you have tried it, let's see. So over here, the molecular formula of this compound is C2. There are 2 carbons and 2 hydrogens. So C2H2. The molecular formula of this is 3 carbons. So C3 and H1, 2, 3, 4. H4. This one has 4 carbons. So C4 and H1, 2, 3, 4, 5, 6. H6. Okay. So if you see in general, then let me prepare a column over here, C and H. I see for 2 carbon, there are 2 hydrogens. For 3 carbon, there are 4 hydrogens. For 4 carbon, there are 6 hydrogen atoms. Okay. Now, what's the relationship over here? Maybe the relationship is 2 into 1. Into 1 is the relationship. Okay. If I try it over here, then this does not give me the answer. 3 into 1 is not 4, but 3. So multiply by 1 is not going to be the answer. What about, okay, over here if we see, then 4 plus 2 is 6. So plus 2 may be the function, plus 2 may be the relationship. So, but if I do plus 2 over here, I should get 5, not 4. So plus 2 can't be the answer. What if I multiply this by 2, 4 2s are 8, and then 8 minus 2 is 6. So into 2 and minus 2. This should be the relation. Let's try it. Into 2 minus 2. So 3 2s are 6, minus 2 is 4. Yes, I'm getting it. Once again, 2 into 2 and minus 2. So 2 2s are 4, minus 2 is 2. So yes, this is the relationship, into 2 minus 2. That means if you have n carbon in a simple alkyne, then the number of hydrogen atoms will be twice the number of carbon atoms, 2n and minus 2. This is going to be the general molecular formula of simple alkynes. So in this video, we looked at the members of the alkane family, the simple alkenes and simple alkynes family. And we also looked at their general molecular formulas. Well, if you are very keen, you would notice that the only difference between alkanes and simple alkenes is that there is a double bond. And rest of the things are exactly the same. So the difference between their molecular formulas could only be because of this double bond. If I had to put a double bond over here, I would need an electron from this carbon and this carbon. So if this carbon lets go of this hydrogen, then it can have an extra electron. Similarly, this carbon can also let go of the hydrogen and get an extra electron. Now these electrons can bond and form a double bond. Okay. So to get a double bond over here, I had to let go of two hydrogens. And that's the difference between an alkane and an alkene. See, this has H2n plus 2, whereas this one has H2n. The difference is of two hydrogens. Similarly, you can note the difference between alkanes and alkynes is that there are triple bond over here, two extra bonds. Now to get two extra bonds, this carbon needs to let go of two hydrogen. Similarly, this one needs to let go of two hydrogens. That means four hydrogens. And that's the difference between alkanes and alkynes general formula of 4 hydrogen. Now with this, we have looked at the general molecular formula of all the 3 families. And by the way, you don't need to mug them up. Whenever you are in need of these, I would suggest you to take some time and try to derive them on your own. Okay? With more and more practice, you will get faster at this. Don't worry.